Story problems that we're looking at today, at least this first piece of it, we're going to kind of continue. I wouldn't actually say are really that much of a story problem at all. Yes, there are words, but that's about it. You don't really need to know much about what those words mean. And these types of problems drive me crazy when I watch students do state testing. Okay, I'm not really sure where or how along the line we have just decided that if it's a story problem, we won't be able to do it, and so therefore we shouldn't even try. Okay, and I watch students all the time, they get a problem like this, they're like, ooh, yep, initial upward velocity, don't know how to do that, turn the page. And just completely leave it blank. Okay, the key here is that I can't tell you every single potential type of story problem like this that you might see. But sort of that continuing theme that we've been talking about of making sure that you're at least reading and making sure you know what you're doing. Are you calculating all that type of math in there right now?
Yep.
Are we listening? Okay, so here is the deal. Story problem says, number one, suppose a football player kicks a ball and gives it an initial upward velocity of 47 feet per second. Do we know what that means? Do we know, have we learned anything about initial upward velocity? No, but let's just keep reading. Okay, the starting height of the football is 3 feet. We represent this width. We don't need to know anything about those first two sentences. It tells us that this is how we are going to represent all of that info. If no one catches the ball, when will it hit the ground? So, let's think about what's actually happening in this picture here. So, sort of drawn a graph. Okay, I got a person who's got a football going on. What's going to happen when this person kicks the football? It's going to go up. And then what happens? It's going to come down because of gravity. Right? This is what the ball's doing. So if no one catches the ball, where is this ball going to hit the ground? In this graph, where is it hitting the ground? Over here, the x-intercept. Okay, so we've already talked about this. How do we calculate the x-intercept on a quadratic? We also might call this, let's put in some other words here. Okay, an x-intercept we said is the same thing as a root, a zero, a solution. How do we find a solution to a quadratic? We solve it. How do we solve a quadratic? Quadratic formula, completing the square, solving by factoring, taking a square root, right? So all this whole entire thing is really saying, look, I'm giving you an equation. How about you solve it for me? We know how to solve this equation because it's already set equal to 0 by using the quadratic formula. Now, we could try factoring, right? We could take negative 16 times 3 and list multiples. Those numbers start to get weird. We could try completing the square, but we'd have to divide by negative 16 and then have a b of negative 47 over 16. Yuck, right? Don't want to go that route. So quadratic formula is our best option here.
Yeah.
Okay, so what does a equal? Negative 16. What does b equal? 47. What does c equal? 3. Let's say you're taking the test. You're testing here, I-step 10, any type of test, you forget the quadratic formula. What are you going to do? Reference sheet. Okay, quadratic formula is always on it. Okay, so we're going to say x equals negative b. So in this case, negative 47 plus or minus b squared minus 4, because that's part of the formula, times a, which is negative 16, times c, which is 3. All over 2 times negative 16. Uh-oh. Does your guys not say this?
No, there's your mind.
Oh.
That's just correct. That's correct.
How in the world did that happen? Anyway. Yeah, just hang on to that. Does anybody else have a wrong worksheet? I'm so sorry. I don't know how that got mixed in.
I'm good.
That is so weird. Okay, so are we okay with where this came from? So now we're going to plug in this stuff underneath the square root, right? Don't plug in the square root sign, as you're going to need a calculator on this. They're weird numbers. Use a calculator. Let your brain not get overwhelmed. We're getting 2401 underneath the square root. Okay, what do we do next? Take the square root. So we're going to square root 2401. We get 49. So I have negative 47 plus or minus 49 all over negative 32. What are we going to do next? Jake?
I forget what it's called, but like you do like 47 plus 49.
Right, I mean, I don't know that there's space. We're just going to calculate both options here. One with the addition sign, one with the subtraction sign. So negative 47 plus 49 and negative 47 minus 49. Please, please, please consider your order of operations here. Right, you cannot type in your calculator negative 7 plus 49 divided by negative 32 equals. Because order of operations say division first. So we need to do the numerator first. We're talking about time, so time would probably make more sense as a decimal. Not that this one really makes a whole lot of sense anyways. So negative 0.0625. Okay, so we have two answers. Do we want to use both of these answers? Can we say that the ball hit the ground at negative 0.0625 and at 3?
No.
No, I'm saying I should know. Why not? I've got two answers. Why not, Isaac?
Because you can't have a negative for time.
Right? Can time be negative? No, right? I can't kick the ball and then like time goes backwards and then it hits the ground. Now, mathematically speaking, it's really giving us this other intercept that's happening over here. Right? But that's not part of the situation we're actually looking at. So mathematically it works, but it's not a reasonable domain for the problem that we're talking about. Time can't be negative. And so what's our answer going to be? 3 what? 3 seconds, because right up here gives us our label of time. Does this answer when the ball will hit the ground? When will the ball hit the ground? After 3 seconds. That's our answer. This didn't require us to know anything about a story problem, agreed? All it asked us to do was solve a quadratic. We can all handle doing that. Yes, Mike?
Don't like plug it back in.
Not in this one, nope. We okay there? Okay. Number 2. A child tosses a ball upward with a starting velocity of 10 feet per second from a height of 30 feet. Okay, when will the ball hit the ground if we represent this motion with? So what is this problem asking us to do?
Solve that equation.
Solve that equation, right? When will it hit the ground? When it hits the ground is an x-intercept. We find x-intercepts with the quadratic formula or factoring or completing the square or whatever. Okay, so same process here. It already equals 0, so a equals negative 16. B equals 10. C equals 3. And then we'll start plugging in. Because with problems like this, story problems like this, that negative 16 is a pretty common number we'll see throughout. That's our gravitational pull. Okay, it's what's causing it to come back down. Okay, then we'll move underneath the square root. We're getting 292 underneath here. Okay, is 292 a perfect square? No. So what should we do next? Okay, so we could prime factor 292 and see if we can simplify it. However, even if I get this simplified, would it make sense to say, oh yeah, that ball is going to hit the ground negative 5 plus or minus 2 square root 17 all over negative 16? Is that how we talk about time?
No.
No. So just like when we were doing our length and width problems, if we knew we were ready for a label, is this problem going to be ready for a label? Yes. If we said we were ready for a label, then we should do a decimal approximation of that square root, because we don't talk about time as a number with a square root in it. Okay, so we're going to use our calculators to just square root 292. And just like we talked about in the last unit, 2 decimal points, round to 2 decimal points. So we'll have negative 10 plus or minus 17.09 all over negative 32. And then we'll calculate both options from there. Negative 10 plus 17.09. So let's see, on top we get negative 0.22. On bottom, once we round, we get 0.85. Tell me if you disagree. Yep.
Mine doesn't say that it's
Did you divide it by negative 32? Okay, so which one of these are we going to pick? The bottom one, because we cannot have negative time. What label is going to go on this? Seconds, because this is time, right? When will the ball hit the ground? So this is a really lame child throwing a ball and it's going thud into the ground. Questions over those two? I mean, pretty straightforward, right? Okay.